Okay, recording. Okay, you can go ahead. The coach and like starts with the problem, and do we see how we can solve the LeetCode?
So we can actually do it together.
Have you already gone through the question?
No, not yet.
Okay.
We're just gonna read it.
So, hi everyone. I am Mennatalla. Today's problem is quite easy and actually quite fun. So we are given an array. Let's say array 1, 2, 3, 4. And we want the product. We want the product of the array. The product of the array in here. So in place of 1, we want the rest of the element. So we want 2 multiplied by 3 multiplied by 4 instead of our first element. Then instead of 2 here, we want the 1 multiplied by the 3 multiplied by 4. So the rest of the element except the element itself. So instead of the 3 here, what we want is 1 multiplied by 2 multiplied by 4. And instead of 4, we want the 1 multiplied by 2 multiplied by 3. Is there any problem understanding the problem itself?
Okay, I didn't understand what they mean by such that answer E is equal to the product of all elements.
Yeah.
So instead of 1 here, in place of 1 here, not in place of 1 like in place of 1,
rest.
I want the rest, the multiplication of the rest. So 2 multiplied by 3. Instead of having the 2 here, I want the multiplication of 1 and the multiplication of 3 and 4. Instead of 3, I want the 1 multiplied by the 2 multiplied by 4, the rest. So I want to exclude the element and then multiply all the rest.
Okay.
Is there any problem in this, the understanding the problem?
Not for me. Anyone have a question? Who did not understand it well? Okay, if not, we continue.
Okay. So basically what I want is the product of the element before let's call it before the I element, the one I am at, and the product of all the element after the element, the I element. Let's call the element I am at, it will be I element. So if I am at 1, 1 is the I element. If I am at 2, 2 is the I element. Is this part clear? I want all the elements, the product of all the element before the prefix of the I element and all the element after. So the suffix of the I element. So what anyone have any idea how we're gonna solve it? I am open to suggestion. I know how I am gonna solve it, but I am open to suggestion.
I guess pointer
At what exactly? Do what exactly?
So we will have to go maybe on each element of array. We can't skip anything. So maybe we're gonna have one pointer that's gonna go on each element.
Okay.
And second part
maybe
is
multiply.
Okay.
Yeah, maybe multiply the elements around it.
Okay. So let's say we have an array of reorder prefix and another array of suffix, the post order. So the first array, instead of I will add it the element before it. I don't have any element before it, so I will replace it with 1. The first one I will replace it with 1 because there is nothing before it. Okay. And the rest I will I have the element before. I will multiply 1 by 1. It will be 1. Let's say the 3, 2 in here, the last element before it, and the 1. I already calculated the pre in the one before. So 2 have 1, so it will be 2. Instead of 4, I have 3 multiplied by 2, so it will be 6. Is this part clear about 3?
Wait. How did we get 2?
I multiplied the element right before it, the one I did not use before. So
okay.
in here,
and all of
I added 1 because 1 will not. If I multiplied by 0, it will be 0, and every element I multiply by 0. So I need something neutral. So I used 1 because there is nothing before it. But in case of 2, I have the 1 here. The 1 here I will multiply by the 1 before, so it will give me also 1. But when I am at 3, I will multiply the 2 by the 1 before it. It will give me 2. In the 4, I will multiply the 1 before it, the 3, with the 2. It will give me 6. Is this part clear?
I think it's clear for me. So this pre-array is just the carrying of the left side numbers on the left side of it.
Yes. All the element at the left side of it. Yes.
Okay, who have any question, please don't be shy. You can just ask. And the coach can clear it out for you.
For that instance, you are dealing with 4.
I did not hear this. I'm sorry.
I'm saying for that case, you are dealing with which number? 4.
Number 4?
Number 4, if you exclude the number 4, if I left number 4 from the array, what I am left with is 1 multiplied by 2 multiplied by 3. It will give me 6. Or basically 3 multiplied by the 2. It will give me 6. I am dealing with the element before the I.
Okay.
Before the I here, not after the I.
Yeah. I'm asking, your current I is 4.
Yes, my current at the last index element, my current I is 4.
Okay.
Is this good?
Yeah, I think it's clear.
Now I am dealing with the other half. What comes after? What comes after? So, like you said, my current element was 4. Just give me a minute. Okay. Not here. Not this. Not this. So I am at 4 right now. What comes after 4? Is there any element after 4? Ignore this. This is just a placeholder. Right now, this is just a placeholder.
Okay. Any
Is
elements after 4? No, there is nothing.
Is there any element after 4?
No.
So I will add 1. 1 is a very neutral element. Now I am at 3. My I is 3. What comes after the 3?
4.
4 multiplied by 1 will give me also 4. So instead of this, I will add 4. Now I am at 2. I can do it like 3 multiplied by 4 will give me 12, or I 3 multiplied by 4 will give me 12. No, something is wrong here.
So
something is wrong here. I don't know.
Why is it 8?
No, 4. Yeah, because I put it 8. It's 4. I put it wrong.
Mm.
That's why I kept saying something was wrong. Please, if I made any stupid mistake like this, please let me know.
Alright, it's fine. I also didn't notice.
No, because when I calculated, it's like 3 and 8. It's completely wrong. So 3 here, I want to multiply it, but I'm not gonna. I want to multiply it by 4 here. So the element before the I in the last and the element. So the element here in the index, so it will be 12.
3 and 4.
So the suffix, yes, will give me 12. Now I am at the first element. What before it, 2 multiplied by 12 would give me 24. So is this part clear now?
Yeah,
Or
I think so. Who have any question? Okay, so the first array it's gonna take care of the left side of each number.
yes.
And the second array is gonna take care of each number on the right side.
The right side. Now,
Okay.
when I say the result array, I will just multiply 1 by 24, it will give me 24. 1 by 12 will give me 12. 2 by 4 will give me 8. 6 by 1 would give me 6. This is the result. I can do this with the other array as well, just the same. It doesn't matter what array. Is this part anyone has any problem or anything confusing?
I think it's very clear. That's really smart. Nice idea.
Okay, so how to translate it into the code? Pretty simple, really.
We need 3 loop or 2 loop.
I will use 2 loop, but I will do these 2 arrays into 1. So I'm not gonna use multiple arrays. I will just do it into 1. So let's say first I will need the length of the array, which will be array ln array. So I will know how long will I loop. Just put this here. So we know this part was done. I will need a post and suffix, a pre and post here. So let's say pre and post or stuff, because we read it as stuff. It will be 1 and 1. And I will need an empty array with the length of this element. So not empty, but I will just put 1 as a placeholder for now, multiplied by length. So this will give me an array that looks like this. There is array right now will be 1 and 1 and 1 and 1. This is the result array for now. This is what this line did, okay? So
but the pre and the...
No, I am not gonna do it in an array. I will do them in the result array.
Okay, so directly in the result.
Yes. I will calculate them directly in the result. So this is how we're gonna do it. Please stop me if you have any problem. Calculate. Or basically just add the pre into array, into result. And let's say for I in range length. The result I will equal pre. I will just add the calculated pre, and After each loop, after each step, I will calculate the next pre. Calculate the pre or the new pre. So this one will be pre multiplied by the element at index I. If we apply this right now, the result array will be one, then one, then two, then six. If the same as the pre-array we calculated before. Is this confusion for anyone?
Okay, I didn't know how would it happen. How did it get 6? So we multiply pre.
Yeah, okay. So the first element is pre-element, which is in this case will be 1. The next we multiplied by the number before I leave the array. Right now the I is 0, so I am at the very first element, which is okay, give me a minute, just let's say the array itself is 1, 2, 3, 4. So the very first element is I is 1. Then I will go to the next and now pre equal 1, because after the then I
gonna be 1
equal 1. So result equal pre equal 1, still equal 1. Now I will calculate the next pre. The next pre is the old pre multiplied by the number
of index 1.
Yes, of yes. So the next pre will be 2 now. But it doesn't matter because this is the next pre, not the one before. This is the next one. I will use it after.
Okay, I see now. So before we go to the next element, we increase.
Yes.
Or like we multiply.
We recalculate. We calculate the new pre. I am calling it array, or is it array or num?
So the prefix always start with 1.
What? I didn't hear you.
The prefix always start with 1.
Yes, 1 is neutral. If I multiplied anything by 1, it will give me what I multiply by. If I multiplied 6 by 1, it's 6. If I multiplied 10 by 1, it's 10, not 1.
No, I said in the first element in the array.
Yes, because there is nothing before it. In the first element of the array, there is nothing before it. So I will just add it 1.
Yes.
So even if the array they give us the first element was like 500, in the prefix we're gonna put 1 as like
yes,
it's gonna be 500 maybe.
So there is array which they give us in the inputs, right? And we create a new array, we call it prefix, that will have the multiplication of the numbers before it. And
yes, but I am doing all the steps at one step. You will see right now. You will see how I'm gonna do it right now. Actually, the next step here. I want this to be visible also. So right now I will add this will be like this. Add the stuff into result. So right now for I in range, and here is the thing. I will do it from the I will start by length -1. till -1, because if I put it 0, 0, it will be inclusive, not exclusive, not inclusive. So I want it I want to include the 0, so I will put -1 and -1 to move backward in the array. So res I will multiply it by the suf. So the first time it will be, it's already 1. I want it's already 6. I have it already 6. 6 and the suffix is 1. So the suff is 1. And I right now is 3. So I am at 4 here. What's after 4 is nothing. So this one, I have the result. So the result right now will have what we did before. So right now it will have the 6. The result right now, actually it will be the 2 and the 1. This is the result. Right now, I didn't do anything because what's after it, it's not. It's only what before it's the first time. But I will recalculate.
Okay, I see. You're gonna use the same array to do it again.
The new stuff.
Nice.
Now I will calculate the new stuff. Stuff multiplied by nums I. So, what is the new stuff right now? Right now, the new stuff is the 6 right now. Not here.
Wait, why new stuff is 6?
Because I multiply the 1 by the number at
length -1. Okay,
not 6.
So
4
from
will be 4 right now. The new stuff will be 4. The same mistake I did before.
it's okay.
The new stuff will be 4 right now.
Length -1.
Nums, yes. So the new stuff is 4. Now when I decrease, now I will be 2. In a 2 will be multiply 2 multiplied by the 4. So the result here will change. Instead of 2, it will be 8, which is what we want in the result.
Wait, I'm confused a bit. The
Okay.
I was 3 become 2.
Okay. I have it here, it 2, right? And the new stuff is 4. So I will multiply the 2 by the 4.
Okay, wait. Now the for loop, is it starting from the number 1 or it's starting from number 6?
No, it starts from the for loop starts from 3.
The last element.
The last element of the array. I'm doing it backward.
Backward. Okay, that's what I was.
Length
Yes.
-1.
Okay.
Yeah. So the first one I kept it as 6 because 6 multiplied by 1 will be 1, and I calculated the new stuff. The new stuff was 4.
Okay, so why I was confused because it show 4 E in range length -1, which is not backward.
Oh, yeah. Okay, this is my mistake.
No, it's okay.
Here it is.
Okay, now it makes sense.
Yeah, I'm sorry.
No,
I wanted to keep the one before, but it's okay.
So we start from left to right in the prefix, and then suffix
And
we start
right,
backward.
left. Yes. Okay.
Is there a reason why it starts backward? Maybe because it's
The
in the
calculation
right.
The same way we did here. The same way we did when we calculated this array. We did it backward. If you remember, we did this array backward.
I actually forgot. Wait. So we ask. Oh yeah, we did it backward. I remember now. We left the left one empty.
What's after it?
Okay, I see. But
Yes.
why we did it from the right? Is it because Is there a reason? Can we do it? Wait. So in the suffix we are looking for
Okay, if
the
we
right
did it
numbers.
here, like 1, I will have to calculate 2 multiplied by 3 multiplied by 4. When I do 2,
okay.
I will have to multiply
I
3
need-
by 4. So
so I
it's
have
much
to start
easier.
from
Yeah, I will have to. I already have this value. I had it by 1. Now I multiply 4 by 1. Now I multiply 3 by the 4 I already calculated. Now I'll multiply the 1 the 2 by the 12 I already calculated. I already did it.
yeah,
So
I see. It's better to start from the right because we will need them after.
No,
Yes.
Monsef, we start from the right because of the concept of suffix and prefix, not because this algorithm. Because the suffix, if you know suffix and prefix already in vocabulary, we have an
Okay.
idea of.
No, suffix no, prefix yes.
Yes, because the prefix we start from the beginning of the word, and the suffix we take it from the last
Last character.
last of the word. Yeah, like
Okay.
I don't know, like stressful, helpful, and watchful, etc.
Okay.
The full it's the suffix.
Thank you.
Welcome.
So now, like we said, we will multiply the suffix by the. We will do the. We are at element 2. So we are at 3. We will multiply this. We will multiply the result, which is we have the 4, and we will multiply it by the result itself. So right now, this 2 will change into an 8. We keep going. We calculate the next suffix, which will be the 3. And and now we are at I1. So we are at 2 here. So we multiply the 1. Okay. We am I doing the same mistake here again? 8 is correct. 6 and 8 is correct. What am I doing wrong?
Okay, is it?
Oh yeah. I multiply it. Yes. I understand. I multiplied by it was 4.
The suffix loop didn't finish yet, right?
The new suffix is 12 because I multiply the 4 by the num. I multiply the 4 by the 3.
Okay.
So the new suffix is 12. Now I multiply the 1 by the new suffix will be this one will be the 12.
Multiply to me.
Yes. And I calculate the new suffix, so I multiply the 12 by the 2. It will give me 24. And now I am at I index 0.
So 24
and I will
multiplied by 1.
Yes, so this is 24. Is there any problem in the anything? Anyone doesn't understand anything in it?
Yes.
Mansif?
Yes.
I think Tidi have a question.
Yeah.
Anyone has any question?
Yes, Tidi, go ahead.
I completely fall out the second for loop, the suffix. Can you?
Okay, you didn't understand the second for loop suffix?
Yeah, the suffix.
Okay. Let's look at the code here. Okay.
Okay.
So the same code, the same problem we have, and the same number and everything. So right now, here is our array, and he calculated the num and pre and post, and here is the result array. And then we enter the first loop. When the I equals 0, the result array is the same. When I is it change here when it's 2.
Yeah.
Because the 2, the value of pre change it. So right now, when it's 3, the value of pre, change it, and here it is. Anyone has any problem following this, or am I going too fast? Because this is the pre.
This is the pre.
Yes.
I
Now,
think this one was clear.
yeah. Okay. Now we enter the suffix. We start from right to left. So start backward from the end of the array. So right now, I equals 3.
Okay.
The result, I will multiply it by post. Post equal 1. So the result will be 6, the same. Now I enter the loop and it's I will be 2. But the post change, the suffix change into, instead of 1, it became 4.
Okay, how did it become 4? We multiply.
Multiplied by num of I. So here's this step. Right now, post
1.
I multiplied. Yeah, I multiplied by nums of I. Nums of I is 4 here.
Okay.
Here there's nums of I is 4. So I multiply the 1 by the 4. Post will be 4.
4.
So now I will go through the loop. The result of I, which is this 2 element here, will give us 4 multiplied by the 2. It will give us 8. Now the post change, because it was 4 before, multiplied by the 3, it will give us 12. Here it is, the post change into 12. So right now we go and multiply the 1 by the 12. It will give us 12. Now the post, I will recalculate the post, which is the 2 by the 12. It gave us 24, the post right now. So recalculate it. It gave us 24.
No.
Is this clear, or still have any problem with it?
It's
Clear? Okay.
We're good?
Anyone have any question? Please go ahead.
I have a question. In the list, when we calculate the prefix, don't take in consideration the last element, and in the suffix, we don't check the first element.
In the suffix,
No.
we don't check the prefix as is of 1 is the element before it. So we're talking here about an imaginary 1. So I am in here, I added an extra 1 as a pre.
Yeah.
I added 1, and as a suffix, I added 1.
Yeah, so we always ignore the last and the first element, the suffix and the prefix.
Yeah, so the first element only deal with the suffix. The last element
Okay.
only deal with the prefix. But the rest deal with both. That's why I added the prefix is 1 and the suffix is 1. This
Because
is
when-
why I am here.
When you calculate the prefix, you didn't check the 4 in the array.
I didn't
Did you
check what?
calculate did you calculate the 4 in the prefix?
So what? I don't get it.
In the prefix, have you calculated the 4
In the
array?
prefix, did you calculate 4?
Yeah, in the last one, the prefix will change. So in here,
It will calculate itself.
but it will not be counted because it will
Yes,
not be
that's
counted.
that's what did I say? In the prefix, we don't check the last element. Isn't true?
Yeah, because we
We check the one in the first.
only behind and
Yeah.
only after.
Yeah. Like
Because I am not using 4 here. I am not using the 4. So why would
Yeah.
why would I add it to the prefix? I'm not gonna use it.
Yes. Okay. Thank you.
You're welcome, but it's okay. So as you see, it's very simple. Lens. Actually, I already have it, so I'm not gonna pretend to write it down. But I already wrote it down. and this is the same code we did. Anyone see anything different? I'll just submit it because I know it should it's working. Okay, it gave me improved performance this time.
Nice,
But
nice,
Last
nice,
time I checked it
nice.
was 78, so I'm not gonna pretend it was I am okay with this one.
Nice work.
Okay.
Who didn't who didn't understand something or have any question?
Can I stop sharing now?
Yeah, you can. Let me share.
Okay.
Let me share and we can go to second LeetCode if no one have a question. Bum, 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 bum. Okay, thank you, Mina, for the amazing explanation and solution. That was a nice idea. I actually didn't do that LeetCode, so I have no idea how I was gonna solve it. But your idea is smart. If someone also did solve that LeetCode, please share it with us in the chat. Now let's go to the second LeetCode, which is coin change. You are given an integer. Okay, let's take it to Excalibur and read it there. It will be easy, I think, to Okay, so this problem, you are given an integer array coin. Okay, this one representing coin of different wait, same doing. I think I copied the wrong example. Oh my god. Okay, this one. So this one, coin, representing coin of different denomination and an integer amount. This one representing total amount of. Oh really? Okay.
Can't see your screen.
Okay. Maybe that. It's about now.
Yes, it's with.
Okay, I was sharing just Discord. Okay, let me repeat. So the second LeetCode problem is this one. Coin change. I just took screenshots and I put them in Excalibur to check them out. So you are given an integer array coins. Okay, this one right here. And representing coin of different denomination and an integer amount representing total amount of money. Okay, so return the fewest number of coin that you need to make up that amount if that amount of money cannot be made up by any combination of the coins. Return -1. You may assume that you have infinite number of each kind of coin. So we have coin 1, 2, 5. So $1, $2, $5. And we have this unlimited, each coin is unlimited. and the amount of dollars we want is $11. So how many coin I can use from the coin that I have to make $11? I can do the coin $1 11 times. I can do 5 twice and add 1 from here. $5, $5.10 and 1. So the output is 3. This is the fewest. So the goal is to get the fewest number of coin that you need to make up. So the explanation 11 is 551. So 551 is the least one we can get, which is 3 coin. Example 2, we have coin 2 and the amount is 3. I can't get to $3 but with like $2, but even if I have unlimited amount of $2, so I can make 2 plus 2 is gonna give me 4. So I will never have $3. So we should return -1 because we can't with $2 coin have $3. Second example is coin $1 and the amount is 0. We return 0. I guess this one is just you don't need any coin to have $0. Okay, what you guys in your mind? What do you think we can solve this? Any idea? If someone already solved it, you can share your idea with us. Okay, take a moment, think. Coin amount. The output is 3. How we can know that? Well, we can. Do I suggest something? Anyone have some suggestion? Can do it with dynamic programming. So we have 11 we need 11 amount, right? So it's like we're gonna create array of 11th element. So 0 1 2 3 4 5 6 7 8 9 10 11. And we can loop on each coin, loop on coin 1 and see how many we need to get to this amount. So how much amount I need to get 0 with coin 0 with coin 1? 0, right? If I have coin 1 $1, how much I can get to $1 with $1? 1. I need $1. How much I can get to $2 with the coin of $1? 2. So basically we're gonna go and put in all the amount of coins we need for the coin 1. Right, we finish with coin 1. Now we're gonna go to coin, the next coin. We can duplicate the same array just to understand it. And now we're gonna do the same thing. How much coin I need to do to get to 0. I guess 0. This one, how much amount of to get, so this one gonna be maybe X, because we can't, right? Can't get $1 with 2. So let's say -1, and how much? Yeah, -1, right? What do you say? If it's not if not possible, is -1. We're just gonna say -1. How much I can get $2? $2. So this is the amount, right? This is the amount I'm looking for with this coin. I can make $2 with 1 coin of 2. So 1. Now for 3, how much coins I can make with 2? It's gonna be okay. I did go a bit outside the algorithm. Let me go back. So the idea is we're gonna see how much we need and also how much we have. So to know for 3 how many coin I need to make 3, I'm gonna do 2. I'm gonna do 3 minus 2. It's gonna give me 1. So I'm like saying I need 1 of 2 and I need 1. So I need 1 of 2. Okay, so to not confuse you, how we're gonna say it. So we have amount 3 and we wanna know how many coin I would need to have this value. We have 2. We can take 2. Okay, here's 1 coin of 2, right? And now I'm missing something, right? What I'm missing is 3 minus 2. I'm missing 1 coin, or like $1. Now $1, how much coin I can get to get $1? I'm gonna go check on $1, and I need $1 coin to get to $1. So I'm gonna do 1 plus 1, 2. So the minimum coins gonna be 2. Okay, maybe I should mix this together to become one array. So at first we're gonna go on the first coin, right? We're gonna fill this this array, and then when we're gonna move to the second coin, which is 2, we're gonna normally start from 2, and then we're gonna move to 5. We're gonna start from 5, and we're gonna fill this or like refill it, because why we're gonna start from 2? Because I can't make 1 with 2 or 0 with 2. So when I'm gonna go to 2, I'm gonna ask the same question, is what 2 the coin value minus amount plus 1. So the coin is 2 minus the amount that I need, 2 is 0. So I can do 2 minus 2, which is 0, plus 1. So I don't need any more coin. It's enough, right? So I'm gonna just put 1 here. So I'm gonna overwrite the 2 I did before, right? Because we are looking for the fewest coin. So it is 2 here because with $1 coin I need 2. But now that I found out that I have $2 coin, I can remove this and put 1 coin because I have it here. So this gonna become 1. And then, okay, before I go to the next, who have any question or didn't understand this part? Please stop me any points. You can ask me. Okay, we're gonna go to.
I'm sorry, I have a question.
Yes, please go ahead.
So, I don't know if this is the same idea you're gonna use, but for what I think, like for example, in my point of view, we begin from the highest coin value, for example, like 5, and we see how many times can we use the coin of value 5. Like for example, we use the modulo symbol, like 11 modulo 5 is gonna give us maybe I didn't think this through. Should we not begin with the highest coin value?
Okay, I think what you're talking about is a greedy algorithm. I didn't solve this with greedy algorithm, but it's possible maybe to solve it with it. I mean, if you have like a solution for it, you wanna like share it with us.
Greedy, unfortunately, greedy won't work. Because let's say we have 1, 3, 4, and 5, and we have the amount as 7. So if I start from the last, I will have 5. I can use another 5, and 4 won't work, 3 won't work, and I don't have 2. So I will have another 2, 1. So it will give me 3 coins, but 3 and 4 give me 7. So it will be faster to go 3 plus 4. So unfortunately, greedy won't work. I thought about greedy, but greedy won't work. This is a recursion problem or a DFS problem, actually. Unfortunately, you have to do it.
I actually didn't see it with the greedy algorithm.
Is the greedy algorithm?
Actually, there is a way you can do it with the greedy algorithm, but you keep the recursion over it. It's too slow. It didn't even pass the LeetCode limit.
Oh, really?
Time limit.
The greedy algorithm, like, how does it work? If you can summarize this.
Okay, who wanna explain greedy algorithm? Because I forgot it how to work fully, but I know it starts like you said from bigger number and you go.
Okay.
I posted the link in chat. Maybe someone can explain it if you can read it.
They work by abstract, like removing the highest number possible. Like we have a list of the coins and the amount, and each time we remove the highest value we can from the total amount. Like each time we have for this example 11, and the highest number is 5. We keep removing 5 every time we can, so we can remove 5 2 times, and then we check if we can, like the next amount that can be used to remove, we check it, and 2 is not gonna work and 1 is gonna work, so we have 2 5s and 1. Maybe that works. Is that the greedy algorithm?
Can Sabah or Mennatalla confirm? Is that the greedy algorithm?
I believe so. You start with the biggest and then you keep subtracting it and until you cannot anymore, then you go to the lowest, to the second biggest, and you keep going. But in some cases, that doesn't work, so you have to loop over it again and skip that current number. So yeah. But in the base, yeah, that's exactly what it was.
Okay, I need to check it out after, like, why in detail it doesn't work with this. But we continue with this one. So this one is dynamic programming. So creating this array, and we're gonna go on each coin, and we fill the array, but we only refill it if the previous value is bigger than the new value. For example, this one, it was before 2. Now that I passed to the coin 2, I understand that to get $2, I can get it only with one time of this coin. So I can edit this number. Then I'm gonna go to number 3. How much I can get $3 using 2. I'm gonna do 3 minus 2. I still have leftover, right? $1. I need $1 and plus 1 of 2. So $2 plus $1. Now I'm gonna go to $1 and see how many coins I need to get $1. It's also 1. So I need 1 coin plus 1 coin of 2. 1 plus 1. So this one have 1. It just coincided that both 1. Maybe it can be like this is 8 and this is like 3. To get 8, I need 3 coins. So 1 is 2. So to get 3, I need 2 coins. I'm gonna edit it because it was before 3, because we were working with 1 coin, which we need 3 coin of $1. Now it's gonna become 2 because I can have $2 plus $1, which is total of 2 coins, right? And then we're gonna move to the second one, and basically we're gonna do the same. 4 minus 2. 4 minus 2, it's gonna give us 2. Now I'm gonna go visit 2, and I'm gonna, so 4 minus 2 plus 1, right? It is 2. 4 minus 2 is 2, like I have a leftover of 2. And how much coin I need to get $2? I need 1. So I'm gonna do 1 coin plus the 1 coin of 2 is 2. Right? Does it make sense? Let's see. So to get $4, I can do 4 of 1 or 2 of $2, which is 2. Now we're gonna go to the next number, 5. Again, we're gonna do the same. $5 minus $2. We are left of $3. I can get $3 with 2 coins. So 2 coins plus the 2 is 3 coins. Is the formula of filling this array, is it clear? Does it make sense? Who is confused? So how I'm gonna fill 6? I'm gonna do the same thing. I need to get to $6, and I have now, we are passing only $2. I have only $2, and we have infinite number of $2. So we're gonna do 6 minus 2. It is $4. So So which means 4 plus 2, it's gonna give us 6. So 2 is 1 queen, and 4, I'm gonna go visit 4 and see what's the value. Is 2 queen also. 2 queen. So the total of queen is 3. Right? Which makes sense, right? I can do $2, $2, $2. It's gonna give me 6. And we're gonna keep going like this until we fill the form again. So this is gonna be 3. 7 minus 2 is 5. 5, I'm gonna go to 5. It's have 3. 3 plus 1 is 4. 8 minus 2 is 6. I'm gonna go to 6. 6, I can make it with 3 quint plus 1 is 4. 9 minus 2 is 7. 7, I can make it with 4. 4 plus 1 is 5. 10 minus 2 is 8. I'm gonna go 8 plus 1 is 5. 5 coin. 11 minus 2 is 9. 9 plus 1 is 6. Okay, now we're gonna go to the third coin, and we're gonna start from 5. From 5, right? Because I know 100% I will not find lowest number of queen using 5 here, right? So I will start because I'm looking for the fused queen. So I'm gonna start from 5 itself. Let's see. Let's update it. Gonna update it here down. So orange. Okay, 5. How much to get 5? Of course it's 1, right? So we're gonna do 5 minus 5 plus 1. 5 minus 5 is 0. I'm gonna go to 0. 0 is 0 plus 1 is 1. 1 queen. Okay, I have 1 queen here. I'm just gonna rewrite it here because it's messy to read. And 3, 1. So 3 is bigger than 1. So I'm gonna edit this one. Let's say the result was 4. I'm gonna keep the 3. I'm not gonna update it, right? Because I am looking for the fused queen. So here we have 1. So I'm gonna update this. We're gonna go to the second number, 6. How much I can get 6? We're gonna do 6 minus 5 plus 1. 6 minus 5 is what? Is 4. Wait, I was reading chat. Is 1. 4 plus 1 is 2. No, I did mistake. 6 minus 5 is 1, so I need to go to the queen 1 and get this value, right? Because it doesn't guarantee that one can have 1. Because for example, if I go to 4, do I gonna find 4 queen? No, I find 2. If I go to 3, I can make it with 2. So I need to visit to see how much queen I can make that's number that I'm missing. So 6 minus 5 is 1. I can make 1 with 1 queen. So 1 plus 1 is 2. 2 is less than 3, so I'm gonna update this with 2. Which means basically 1, 5 plus 1. 7. Let's go to 7. 7 minus 5 is 2, right? I'm gonna go to 2, take this number 1 and add to it 1 and put it here. 2. 1 plus 1. Something may be confusing is like why we add that plus 1. So we said like we need $7, right? We need $7 and we have only $5. Let's say I have in my pockets $5. So I'm gonna do, okay, 7 minus 5. How much I'm missing? I'm missing $2. And how much coin I already have? I have 5. Okay, here is it, 5, which is 1 coin, right? 1 coin. So how much coin I can get to $2? I'm gonna go back to here and see the number 1 coin. So 5 plus 2 is 7. I can make this one with 1 coin and I can make this one with 1 coin. So that's why it's 2. So we could do 7 minus 5, 2, and wherever we can make this 2 and the plus 1 of the 5 that we have in our package, right? We go to the second element, 8. 8 minus 5, 3. We go to 3, it is 2. 2 plus 1 is 4. Sorry, 3. We go again, 5 minus 9 minus 5 is 4. We're gonna go to 4, 2 plus 1, 3. Go again to 10. 10 minus 5 is 2. I'm gonna go to 2. I can make it with 1. 1 plus 1 is 2. And where is it? 11. Okay, so 11 minus 5 is 6. 6 is 2. 2 plus 1. 2 plus 1 is 3. And I'm gonna update all of them, right? 4 is bigger than 2. 4 is bigger than 3. 5. So I'm gonna update all of this, because this one is less. And now I can only access, we looking for amount of 11, right? I just access the 11 and I get the fewest coin possible to make 11, which is 3, which is what we're looking for. So this is the algorithm for this problem, or one of them. I'm sure there's many. Now, who did not understand how it works, or maybe you're confused about the problem itself? Any question? Please go ahead. Do not be shy. Okay, Abdo, go ahead. Which part, please?
Mostly, should I have an idea about the greedy algorithm before doing this?
Yeah, you have another idea you want to share? Go ahead.
No, I say, should I have an idea about this greedy algorithm because I haven't used it before.
Oh no, this is not greedy algorithm.
Okay.
This is, I think, bottom-up dynamic program or top-to-bottom. I confuse them both. It's one of them. So basically, we just create an array and we process coin by coin, and we compare. For example, if I find I can make, for example, notice here it was 5 at first, then it's become 3, then it's become 1. So it's like saying, it's like I'm asking you, if I give you $1, how much of $1 coin you will need to make 5? You're gonna tell me, oh, it's easy, I need 5 coin, right? And then I could tell you, okay, what if I give you $2 and you're gonna keep that $1 that I give you before? How many coin you need now? You're gonna say, okay, two coin, and each coin is infinite, right? So you're gonna say, okay, 5, I need 2 coin of 2. Okay, here's 1 coin, and 1 coin of 1, right? And you're gonna say, okay, 3. So you're gonna go back in same case, index of 5, and you're gonna remove, scratch on that 5, and write again 3. And then I'm gonna tell you, okay, what if I give you, on top of the 2 and 1, I give you also coin of 5, which is unlimited also. You're gonna say, okay, it's easy. If I have 5, it's only 1. I need 1 coin. Then you write 1 coin, you scratch on 5 or on 3. You know what I mean? So you basically do the same thing for all of them. You just go 0, 1, 2, 3, 4, and then at the end, the result's gonna be a array that have the fewest possible solution. What do you think, Abdul? Is it clear, the idea? Yeah, you're welcome anytime. Okay, happy Miriam that you did understand it. Okay, now if you understand the core idea, you can code it with any language. It doesn't matter how you're gonna do it, but let's do it with the Python. Okay, so let's do. So we can do a pseudocode. I almost say bytecode style. Okay, so if we did pseudocode for this, just to like follow more easily, the first thing we did is we create this array, right? So create array. Now this array we can put so the array is gonna be for all the amount. So if we have amount 11, we're gonna create array total of amount. Okay, so here is it. We have this array. Now we will create in this array a default value, right? Because we would not guarantee that we. So for example, here we have from 0 to 11. At some point, we might not be able to answer all of them. For example, if we didn't have $1, if they give us just 2 and 5, what value gonna be here? This is gonna be 0, right? But this one, because 0 it gives you 0, but this one it's gonna be impossible. So like -1. Impossible, right? I can't make $2 and $5 and get the amount 1. So we need to give it a default value so we can understand if we can get to this amount. So at first all the arrays gonna have -1, or let's do infinite, because maybe we're gonna have, I don't know, I think -1 will work, not sure. But did you guys understand here what he meant? So someone said, hey, give me amount of 11, I give you 2 and 5, and then I'm gonna go to the 2, and I always generate this array from 0 to 11. So I'm gonna go to 0. How much I need to get to 0? How much I need to get to $1 with 2? I need to do something here. -1. It's impossible. And so I'm gonna give this array a default value, create amounts, give array default value. Let's go -1. I'm not sure if it's a good idea, but we can test it. Okay, now we have array of all -1, -1, all of it. And the first index, we're gonna put it on 0, right? Because it's gonna be always 0. Set first index to 0. And then loop on h_quen. And we are looping on h_quen, loop on each element in each amount, right? That's what we did. We were like, we stop the pointer here, and then we keep looping 0, 1, 2, 3 until we find 11. Then we move to the next quen. And notice something we did is, if we are in 5, we actually start from 5, right? We don't start from 0, because we know that we're not gonna find with 5 4 or 3 or 2. So we need to do that in here. Loop on each amount, starting from amount itself. I hope this one is clear.
Sorry.
Yes, please go ahead.
The -1 default value. Could you explain it again? Why it's -1? I just got the part to say that for 0, there is no amount of there's no coin we can use to get 0, and also 1. But why are you using -1?
Okay, so I got it from here, but I'm not sure if it's gonna work. So here they say we have quen 2, and we are looking for amount 3. Can I make $3 with $2? I can't, so I'm gonna return -1.
Oh, okay.
But if I have $1 and I'm looking for 0, I return 0, because I'm looking for 0 and I can make it with anything, nothing. But let's test it if it's gonna work. If not, we can use some another flag. So loop on each amount, starting from amount itself, right? That's what we did. And when we're doing this, we were doing basically like
Mosek,
yes,
maybe if the amount is less than the coin, we should return the amount. Like if we have the amount is 3, the coin is 5.
Okay, so if the amount is 3,
we should return amount
this means
is
0, 1, 2, 3. So, oh, you mean
like in the example of 0 in LeetCode example, they return 0 not because they put 2 in coins and the amount, not 1 in coins and the amount is 0. So we can't go back backward. That's why they return amount. In the example level 3.
Okay, so 0. Yeah, we can just do if amount 0 returns 0, like a condition. Like here.
No, I guess they didn't return it because it's zero. They return it because it's the amount it's less than the coins.
Less than the coins.
Yeah. So it's
like the total of the coins.
Yes, like let's give another example, like coins.
Okay, but this one is less too. Or like, let's
No,
see.
it's not. The amount is.
Okay, so if it was $2 and they have 5, should they return 0?
I guess we should return 2.
Okay, so why
like
2?
By the way, what is the return value? What will return here?
So we have $5 and the amount I'm looking for is 2. It should return -1.
It should return 0.
Yeah, it's -1.
Oh, it's -1. It's -1, yeah.
Oh, it's -1. Okay.
Because like they say return the fewest number of coin that you need to make up that amount, which is 2. If that amount of money cannot be made up by any combination of coin, return -1.
Okay, sorry.
No, it's okay. Your idea is cool because we can actually do, because if we can check for amount 0, we can return 0 directly. We don't have to.
Yes.
Because it's like how much coin I need to make $0. I guess 0. So it's like it's gonna be always there. So we can add it here, like if amount equals 0, return 0. This way we save time instead of like doing a whole loop on everything. Now we are looping on from the start of that amount, right? And remember we're doing this math equation on each element we loop. So the math equation was like something, we take this value of the amount, so take value of amount we are on minus the value of minus the coin, right? The coin we are on, and +1, and we save it. We save this value in the one that we are on. So for example, if we're in 6, we're gonna save this value here if it is less than the value that's already there, right? So the idea of main come here. Main minimum of between this and the value that was there. Okay, let's just write it here until we in the code. But how can write that in the code? We can say create an array total amount. So we can say save in the amount the minimum between the current amount and this. Start from the amount itself. Okay, now okay, this one is itself inside this loop on each element, each amount, starting from the amount itself, then save the amount, save the amount in the amount, the minimum between the current amount and the value of amount quant like current amount. but that's not the formula that we did it. We actually did, let's say we did 6 minus 2. It give us something. It give us 4, and then we log 4 on the table. So this is like gonna be the index. So amount, it's gonna be index. So I'm gonna do like 6 minus 4, 6 minus 2 is gonna be 4. Now I'm gonna go to the amount and look for the element 4, and that value I'm gonna add to each one. I hope when you code it will be more clear. And
I'm sorry, Mansur.
Yes.
Mansur. Can you explain this?
okay,
Can you repeat it? The last one. The why you are taking the minimum.
okay. So let's say, do you remember when we did with the 2? We were looping on 2. We found out that we need 3 coins, right? And we saved 3 coins in 5, right? Remember that?
Yeah.
But when we jump to the next quant, we found out that with 5 I actually need only 1.
Oh yeah, I got it now.
So I will see, it's like I'm gonna compare 3 with the new value. The minimum on 1 is what I'm gonna save again here.
The minimum number of steps. Okay.
Yeah. Okay, after that it's gonna keep looping on all of them. So this is basically what we did until we found out at the end when it's finished, then we can access that amount we're looking for and just return it. So when the both loop gonna finish, we wanna return, so we're gonna check if amount. We can return the amount directly. Oh yeah, we can return amount 11, right? We're looking for 11. We can do amount and then amount. So the amount is parameter that they give us, and the array we call it amount. Let's do s, for example, amounts. But I have no idea. Maybe it will work, maybe not. Let's see. I mean, I tested it before. It did work, but not like this one. Okay, let's see how we can put this one. So we said if amount equals 0, return 0. Create an array total of amount. So let's create amount, array we call it amount, and we're gonna put inside it like -1, right? So like -1 in. So this is gonna be default value of it in the amount. Do we need to do +1 or not? Because we have 0, right? Because now if they say 11 and 11 amount, I need to for example here 11, but they're actually 12 because we have 0 here. So +1. And give array default value -1. Okay, that's what we did here. Now this gonna create 12 elements of -1 like this. Like this. 12. In the case the amount was 11, then set first index to 0. Okay, so amount index 0, we're gonna put 0 because looking for $0 gonna be always 0, right? And loop on each count. So for we have count. Yes, please. Yes, please.
Do you mean the amount plus 1, the length of the amount, the length of the array amount?
Yeah. So for example, they say we're looking for amount 11. So what we do is we create an array that's gonna do from 0, 1, 2 until 11, right?
Yeah.
And then we keep filling this array, right? Now, if I want to generate this array, how many elements it have actually? It's 12, right?
12. Yeah.
So the 11 amount that they give us plus 1.
So in that case, isn't it going to be length of amount then plus 1 length of?
This is integer.
Okay.
Wait, length of amount?
Amount is the array.
So this line is gonna let's say this is a array, empty array. It's empty, right?
Yeah.
Which means it's like this. It's empty. What I'm doing here is like I'm saying, hey, add to this array 12 elements, which is this right here, 12. It's like 11. Or like let's do 12 right here.
All right. Yeah. It's an integer.
Yeah. So 12 elements. That's gonna be -1. So this all -1.
All right. Thank you.
What we gonna do here? Okay, so we were here loop on each count. Okay, we're looping on each count. Loop on each amount, starting from amount itself. So we create this array of amount, right? So loop on each amount, starting from the amount itself. So for example, if I am in amount I think what I meant here is starting from coin itself. Loop on each amount starting from the coin. For example, if I have if I am in coin 2, I'm gonna loop on this amount starting from 2, not from 0 or 1, right? Because if I'm in 5, I'm gonna start from 5, because wherever before, because I know I can't make $4 with $5, right? It doesn't make sense. So to do that, we're gonna do starting from concept. So for another loop on each amount is array. So amount in amount, but how I'm gonna start from itself? I guess I need to use a range, and using range I can tell it to start from the coin and stop on the amount plus 1. So basically what this range gonna do, it's gonna generate numbers. So if the coin was 5 and the amount plus 1 is 12, it's gonna generate number from 5, 6, 7 until 11, and it's gonna stop, which is the index that we want. Okay, here we go. and then we're gonna do the second part, which save in the amount, the minimum between. Okay, so save in amount is this one, array, and we have index amount. Let's call it index amount. We have the index of amount, right? We just call it E. So this E is this number right here, 5, 6, 7, 8, right? Now save in the amount. What we're gonna save? The minimum. Okay, the minimum, which means we're gonna use min between the current amount. Okay, current amount is this one. Here's it. And the second value is what? And the value amount minus current. So amount amount. Okay, how I can get this amount is the index, right? So index minus current 1 plus 1. Amount minus current plus 1. Let's call this okay, let's see how this work here. So first let's understand this part. What is this? So we said amount, right? And we can access E minus queen. Now what is E in this case? If I was in 5, for example, and I was here, let's say I was here 7, queen is 5 and 7 is the amount. E, it's gonna be 7 minus C, queen 5, right? Isn't that what we're doing? Is we do 7 minus 5 and then we go and see what is that value. 7 minus 5 is 2, and then we go to 2, amount of 2, and we bring this number, and then this number we add to it plus 1, which is 2. So that's what we do. When we go into amount, we calculate the index, which is 7 minus 5, it gives us 2. Then we go to amount index 2, and then we get this value, which is in this part right here, and then we add to it 1, and then this gonna give us 2. We're gonna compare it with the old value that was in the index 7, which here was 4 and 2, the minimum is 2, so this gonna be removed and save 2 inside. Okay, what next after this one? That's it. This gonna keep looping on all coin, all amounts, and at the end, hopefully I think it's gonna be amount, return the amount, index amount, return amount, but I'm not sure if this is correct. Let's try it. But before we try it, who have a question about the code itself or pseudocode? Who is? Who did not understand any of them? Any question? Okay, let's run. I guess no one have question. Amount. So it said list assign index out of range. Oh, I forget -1 here. We have 1 expected 3, it gives us -1. So maybe this does not work. So
in the for loop, you're taking the minimum, your amount I equal minimum amount I, which you already initialized by -1. So it's already very low. It will always give you -1.
Oh, okay, yeah, because it's -1. So we can do infinite, max infinite.
Or you can do the amount. because it will not increase on the amount. If and in the return condition, if amount equal amount equal amount itself, like in this case 11, it will be -1. Else it's whatever the minimum amount is.
Okay, that's smart. So we can check if it is -1 here. We're gonna directly sign this, right?
No, I was thinking in the amount rate.
Here?
Don't initialize it with -1. Yes, you
Here?
initialize it with the amount, and in the return statement, you just make sure amount -1 does not. If it's amount -1 equal amount.
What if we did infinite, like a max
that
number?
will work. It will work.
What error? Inf is not. I think I write it not correctly. Float.
I think you still have to maybe check at the end if it's infinite to return -1.
Oh, yeah, because we are here. Okay, so we need to add a check here. If amount equal or like doesn't equal float infinite, that means we're gonna return it. Return this value, but else return -1, which mean
Else you wrote it as.
oh yeah, let's see. Okay, finally, let's go. Okay, it's nice. Okay, let's try to explain what happened. So it did not work using -1 at first because we are adding here the minimum, right? So like if I find 2, for example, and by default it have -1, so like the code is gonna be like, okay, I found 2, but I can't update it because -1 that's already there by default, it's less than the value I got. So the other idea is like we put infinite number, which is like, think about it like a flag of like the max possible number, like the infinite number, like the biggest number ever. It's like a flag, and if we find that flag there, that flag is gonna allow us to compare, because the default value is gonna be so bigger and we are looking on minimum, so it's gonna be possible to update it. And then we check if it's the flag still there, that means we didn't visit at all that amount, right? Which mean it's not possible with any queen to have this amount. So automatically if we find this amount we're looking for have infinite number, we're gonna return -1. Okay, who have any question, please go ahead, don't be shy. Nada? Okay, hope it's clear. I'm sure there is many solution for this problem. Sure. Yeah, I guess that's all for tonight. Yes,
the code.
okay. So the code. Python. So the next session gonna be Saturday. we have validated binary search tree and number of island. We think we already did that one. And Sunday we have rotate in orange and search in rotate sort area. If you want Saturday to host any of this LeetCode, or even Sunday if you want to host search in rotate, you can. Stage is all yours. Okay, have a good night. We keep learning together. Hopefully we finish this 12 week. We be strong on analyzing problems and solving algorithm problems. That's it. Have a good night.
Night.
Have a good night.
And in time for Champions League.
Maybe.
Yes.
Maybe. Good night.